So now that we've given an overview of parallel streams and talked a bit about how it works under the hood and also covered some of the things that will cause you some grief if you're not careful to use stuff like no side effect behaviors, let's turn our attention to a case study that will help put all the pieces together and make it more clear. This particular case study is the SearchStream gang case study, and there's a whole bunch of different variants of this using different concurrency models. So we have stuff in here that uses sequential streams, sequential loops. We have parallel streams, a couple different variants of parallel streams. We have some other frameworks like reactive streams, like RxJava. And we'll talk about how they perform under different scenarios as we go through this. And remember, this particular program is going to be searching for phrases in the complete works of Shakespeare. That's what it's doing, which, if you think about it, is a good example of a nice, embarrassingly parallel processing. So we're going to look at a couple of methods that are part of a class that's in this code base called SearchWithParallelStreams. And this is the one that's going to be parallel streams. And we're going to look at the process stream and process input methods. These are what are called hook methods. They are derived from a superclass and provided in different ways depending on how it is we're doing different concurrency strategies. So this is roughly what the code looks like. So here's process stream. You can see it's got a couple of methods in it. Some of these should look familiar by now, like map. And then process input, likewise, has a couple of operations that you should be familiar with, like filter and collect and so on. So what do these methods do? Well, let's start with process stream. What process stream does is it uses a parallel stream to search a list of input strings. And each input string contains a complete work of Shakespeare, like Hamlet, Macbeth, Othello, Twelfth Night, Julius Caesar, whatever is your favorite Shakespeare play, it's in there. And so those are the input strings, and we read those from input files. This parallel stream, of course, uses the common fork join pool of worker threads. No surprise there, they all do that. That's what parallel streams does. And it returns a list of lists of search results. And we'll talk later when we get further along about why we have a list of lists of these things. And each of those lists of lists will include the search results that happen to match. There's also another method, hook method, called process input. And this is basically a subroutine that's called by process stream. And process input also uses a parallel stream to search each input string to locate all occurrences of phrases in that particular string. So once again, imagine we've got Hamlet, which is the input string, and we want to search for all the famous phrases in Hamlet, such as brevity is the soul of wit, or to thine own self be true, or neither a borrower nor a lender be. It goes on and on and on. Shakespeare certainly wrote a lot of cliches, didn't he? So this parallel stream also, of course, uses the common fork join pool of worker threads, because that's pretty much what you're stuck with when you're using parallel streams. And it returns a list of search results that indicate whether or not there were matches that occurred. And it might be empty if there were no matches. So if you were looking in the play Hamlet for the phrase, my kingdom for a horse, you wouldn't find it in Hamlet because nobody says that in Hamlet. That's in some other Shakespeare play. Or out, damn spot. That's another classic phrase, which is from Macbeth. So that's just a really quick overview of the case study. And what we're going to do now is we're going to take a look at how all the different pieces work under the hood, and you'll see how easy it is to use parallel streams for this type of an embarrassingly parallel program.